Did you know the moon is rusting? Yes, you heard that right. Something you might associate with old cars or abandoned ships is happening to Earth's very own natural satellite. But how on Earth, or should I say, how in space, is that even possible when the moon doesn't have water like rivers or oceans, and it definitely doesn't have rain? This bizarre lunar mystery has baffled scientists, and today we're diving deep into the cosmic riddle to uncover the truth behind the reddening of the moon. Let's start with the first fact. Rust, or more scientifically speaking, hematite, is a form of iron oxide. On Earth, rust forms when oxygen reacts with iron in the presence of water. But here's the thing. The moon is a dry, barren world. Its surface is covered in fine, powdery dust and rock called regolith. It's an airless, waterless desert of cosmic proportions. So how did scientists find traces of rust on the moon? That's where things get mind-blowingly fascinating. In 2008, India's lunar mission, Chandrayaan-1, carried NASA's Moon Mineralogy Mapper, also known as M3. This high-tech tool wasn't just good at mapping minerals, it had the ability to detect specific chemical compositions. When M3 surveyed our lunar neighbor, it detected something unexpected: iron-rich compounds that shouldn't be there. At first, the results were questioned. Was it a mistake? Were the tools malfunctioning? Scientists scrutinized the data, and over time their suspicions solidified. Hematite, a clear sign of rust, was spotted on the moon's surface, hiding in plain sight. Let that sink in for a second. Our little airless companion has rust. But wait, it gets even weirder. The rust isn't everywhere. It's mostly on the moon's side facing Earth. Strange, right? This added an extra twist to an already bizarre discovery. Here's the thing. To solve this mystery, we need 3 ingredients: water, oxygen, and a reactive element like iron. We already know the moon has iron in abundance. Just take a look at the vast gray plains of lunar basalt. But water? Oxygen? Where could they possibly come from? In 2020, a team of scientists from NASA, the University of Hawaii, and the Jet Propulsion Laboratory came up with a bold hypothesis. Could it really be Earth that's causing the moon to rust? And believe it or not, the answer is probably yes. Earth and its atmosphere may be playing a critical role in this otherworldly process. While the moon itself is airless, it's not totally removed from Earth's influence. Every month, as part of its orbit around us, the moon drifts into Earth's magnetotail, a region shaped by Earth's magnetic field that trails into space like an elongated shadow. In this magnetotail, something incredible happens. Particles and ions from Earth are transferred to the moon. Specifically, oxygen ions from Earth's upper atmosphere hitch a ride and travel to the moon. Bingo! That's one key ingredient for rust: oxygen. But what about the water? Well, here's the kicker. The moon actually harbors tiny quantities of water. Over the past decade, lunar missions have detected evidence of water molecules clinging to the dust and rock on the moon's surface. While this water existed in minuscule amounts and mostly appeared in cold, shadowy regions near the moon's poles, it was enough to contribute to chemical reactions, especially when combined with Earth's oxygen ions. Now, all 3 ingredients are accounted for: water from tiny lunar pockets, oxygen ions from Earth's magnetotail, and iron from lunar rocks. It's like a cosmic recipe for rust. But here's an important note. Because the moon lacks a substantial atmosphere, there's no rain, no wind, and no flowing water to corrode it at the rate we see on Earth. Lunar rust forms incredibly slowly because space is, well, not conducive to weathering. Here's a curveball for you. Another theory suggests that micrometeoroids, those tiny speeding pieces of space dust constantly bombarding the moon, may be releasing the iron from lunar rocks. Think of them as cosmic needles, poking and exposing the iron while kickstarting chemical reactions. Under the influence of these tiny impacts, along with oxygen ions from Earth and bits of lunar water, hematite, or rust, is steadily born. So, why do we only see rust on the moon's Earth-facing side? The answer lies in this unique Earth-moon relationship. You see, the moon's orbit is tidally locked to Earth. This means it always keeps the same side facing us. As a result, that side gets bombarded more frequently with Earth's oxygen ions during its journey through the magnetotail. The far side of the moon? Not so much. It's as if the moon's leading face is privy to a very specific and rare rust-making process unavailable on its flip side. Now you might be thinking, is this new rust changing the moon as we know it? Not exactly. The amount of rusting is very minimal and doesn't visually alter the moon from here on Earth. That said, from the vantage point of space science, this discovery is monumental. It provides both a deeper connection between Earth and Moon and a new way of understanding how chemical reactions can occur in extreme environments, far beyond what's possible on Earth. So, what does this all mean for future exploration? Scientists speculate that this phenomenon could help uncover ancient lunar secrets. By studying these rusted patches with better tools in upcoming missions, we can learn not just about the moon's history, but incredible details of Earth's atmosphere from millions or even billions of years ago. The rust holds information, an ancient fingerprint from a time we've never seen. In the world of space exploration, it's discoveries like these that shift our sense of wonder. They remind us that unexpected outcomes, like rust on the moon, can tell stories as grand as the universe itself. Did today's revelation about our rusty moon surprise you? Share your thoughts in the comments below, and don't forget to hit that like and subscribe button for more mind-blowing 4K science content every week. This outstanding video was crafted by VidWiz. Want your own exciting videos for fun or profit? Click the link in the description to get started today. Thank you, and keep that curiosity shining, sparklings.